Hello everyone, this is Shubhangshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. So my today's topic is circuit theory and networks. So this is the lesson plan of the circuit theory and networks. The subject is basically designed for the basic concept of electrical circuit. This course is available both in BTech and diploma courses. And this is the outcome of the circuit theory and networks. There is total 5 numbers of outcome, course outcomes. Now today's topic is loop analysis or mesh analysis. So first let's discuss on the objective of this lecture. First one, to introduce the mesh or loop current method. Number two, to formulate the mesh current equation, and then to solve electric circuit using the mesh current method. So mesh analysis or loop analysis. Look, this analysis is developed by applying KVL around meshes in the circuit. The loop analysis results in a system of linear equation which must be solved for unknown circuits, reduces the number of required equation to the number of meshes, can be done systematically with little thinking. As usual, be careful writing mesh equation, follow sign convention. So for this case, sign convention is very important. Now the steps to solve any circuit using mesh analysis. So what are the steps? We have total 4 steps to follow to solve any circuit or to apply mesh analysis for any circuit. The first one is identify the number of basic meshes. So first we have to identify how many meshes there. So selection of that is very important. Second one is assign current to each mesh. So current assignment, or you can say you have to assign particular current for every mesh. Then apply KVL around each loop to get an equation to terms of the loop currents. And the fourth one is solve the resulting system of linear equations. So the first is identifying the meshes. So in the top figure, look, we have two voltage source in a given figure, two voltage source V1, V2, and 3 resistances there, each carrying 1 kilo ohms. So here two meshes, one is mesh 1 and second one is mesh 2. Now we have to assign the mesh currents. So the left hand side mesh 1 we assign the current is I1, and the mesh 2 we assign the current is I2. Here both the current direction is clockwise direction, but it is not mandatory that all the time we have to consider the mesh current in clockwise direction. It's totally depend on the user or the someone who is solving the problem. You can consider both the current direction as anti-clockwise direction, or I1 clockwise, I2 anti-clockwise, and or I1 clockwise, I2 clockwise, I1 anti-clockwise. So anything, it depend on the user, it depend on you. Now after assigning the current, we have to develop the equation. So how to develop the equation? This is very important. On the topmost left hand side resistance, you can find that current is going from left to right. That means here the rotation, the direction is clockwise direction. And the top of the resistance, it is showing that the voltage is VR and the resistance value is R. On the left hand side, the polarity of the resistance is positive, and the right hand side the polarity is negative. So for the calculation purpose, for the understanding of the calculation, we can consider, though there is no starting end point of the resistance, but for this case we can assume or we can consider that the current, as per the flow of the current, the starting point of the resistance is positive and the end point is negative. If we consider like this, then the solution method of the circuit will be easier. So here, using the Ohm's law, we can say that VR equals to I1 into R. But the right hand side, figure, I1 is rotating clockwise, but I2 current is rotating anti-clockwise. But the direction is opposite direction. So for opposite direction, VR value is equals to R into I1 minus I2. That means positive to negative, we are considering positive. So it is I1 minus I2. So now go to the figure, the same figure, so the last slide. So using the below figure, we are going to develop the equation. So mesh current equation. So the first mesh, look, as I said in the last slide, follow the direction of the current. So here the direction of the current is clockwise direction. So I already told that consider the starting point of the resistance, though there is no starting point. I'm mentioning this repeatedly. The starting point positive, end point negative. Starting point positive, end point negative. So I1, that means here the voltage is I1 R1 plus I1 R1. Plus to minus means plus. Here also R3 into I1, but this is minus I2. Why? Because if it is plus to minus, so the direction is minus to plus. That means R3 into I1 minus I2. And then I1 current is flowing, and here it is minus to plus. That means minus V1. So I1 R1 plus R3 into I1 minus I2, R3 into I1 minus I2 minus V1 equals to 0. And for the second loop, same way. If we start from this position, plus minus, so plus minus means I1 R I2 R2, I2 R2 plus V2, V2 plus I2 minus I1, I2 minus I1 into R3. So R3 into I2 minus I1 equals to 0. I2 minus I1 into R3 equals to 0. So in this way, we can develop the mesh current equation. Now, solving the putting all the values of resistance, voltage, current as per the requirement, we can find out the value. What is actually we can find either current or resistance for the requirement of the question. Next is some cases is there, some special cases for this type of mesh current method. The case number 1, when a current source exists only in one mesh. Look, the last figure there is two voltage source on both side of the circuit, but here one voltage source 10 volt and another one is current source. So how to solve this type of circuit? So for loop 1, this is same like the last previous circuit, previous method. Apply here 4I1 plus minus 4I1, 6 into I1 minus I2, 6 into I1 minus I2, minus 2 plus minus 10. That is equals to 0. Next for loop 2, simply write I2 equals to minus 5 ampere. Why? Because the direction of current source and the direction of loop current is opposite. So we have to write only the value of the I2. Don't need to write the loop equation for this case if there is any current source present. Next, case 2, a super mesh. So the question is, what is super mesh? Super mesh, when a current source exists between two meshes. Look, here a current source is existing, 6 ampere current is existing between two meshes, I1 and I2, the left and right hand side meshes. For that, if any current source is existing between two meshes, that case we have to apply super mesh. So what we have to do for that, this type of circuit, exclude these element where the current source, we have to exclude that particular branch where the current source is installed or present. So after excluding, we find this figure, the same figure like this. So for figure B, we have to develop an equation. So what will be the equation? Look, 6I1, don't be confused. This is for, this I1 current is only for 6 ohms and I2 current is for 10 and 4 ohms. So 6I1, same direction, that means 6I1 plus 10I2 plus 4I2. But here it is minus 2 plus, that means minus 20. equals to 0. This is one of the equations. So you have to develop another equation with this excluded element or excluded branch. So what will be that? Look here, the I1 is coming from upward to downward, I2 is downward to upward. So this is, we can say I2 minus I1. So what is the resultant current for this section? This is 6 amperes. So I2 minus I1 equals to 6. That means you can say I2 equals to I1 plus 6. Now solving these two equations, we can easily find the value of I1 and I2. So the value of I1 equals to minus 3.2 ampere and I2 equals to 2.8 ampere. So in this way, we can solve the problem of super mesh. Now this is the reference for this PowerPoint presentation. And thank you all for watching.